Hey, John.
Hey. Wow, how's it going?
That sounds about right. So right now I just have it on full screen. Is there like a presentation? Oh, I think you have to, yeah. In Windows, it's like you right-click on it, and then you say hide or something like that, right? Oh, could be. Yeah, lock text, right? Oh no, spoilers! All right, I think we're going to get started. All right, so hi everyone. My name is Ryan Bossart. I'm one of the co-chairs of the user group here, along with Brock Noland and Brad Rubin. And Brad is from the University of St. Thomas Big Data program here, and so they're kind enough to provide us this space. We have John here today to give the talk. A few announcements before we get started. So those of you who are watching the Meetup site might have noticed that as of this week, we changed the official name of the Twin Cities Hadoop user group to be the Twin Cities Spark and Hadoop user group. So a very subtle change, but it's really in recognition of two things. So number one is just the growing influence of Spark in the Hadoop ecosystem. And then number two is to help Spark users and Spark developers basically find our group more easily. So I don't think the content is going to change at all. So if you look at what we've been talking about over the last 2 years, I think probably 75 or 85% of our talks are already about Spark explicitly or have some component of Spark. So that will remain to be true. It's just those two advantages that we get. The other thing that I wanted to announce is that a couple pieces of feedback that we consistently receive here at the user group is, number one, that Thursday may not work for me. Thursday's a bad night for me. And then the other thing is that maybe it's hard for me to get over to St. Paul. Maybe I live over in Wayzata or Eden Prairie or something like that. So what we've done is we've added a new meetup that's part of the Twin Cities Spark and Hadoop user group that's going to meet every other month. So this user group right now meets every other month here at our great space at the University of St. Thomas. But starting next month on February 24th, I believe, we're going to have another meetup that meets on the off months here over in Eden Prairie. And so WAN Corporation has been kind enough to host the first meetup. And we're going to have Dave Hendrickson from Thomson Reuters come and talk about how they're using Spark at Thomson Reuters. So for those of you in the western suburbs or who just want more Twin Cities Hadoop user group, then you can go head over west, and there's going to be even more content there. I think those are the announcements before we get started. I guess, is there any group announcements? So if anybody in the audience wants to make any announcements or anything like that, then this is a good time to do that. Brad?
Maybe John would like to mention the social data science meetup that's going to start meeting here too.
Yep. So I'm also running another meetup called Social Data Science, where we apply data science to nonprofit problems. And it's going to start meeting up. I think we have space reserved for February 6th. But if you search meetup.com, social data science, or you go to socialdatascience.org, you should be able to find our meetup group. We typically meet maybe about once or twice a month, and we're very focused on being hands-on. We're not necessarily big data, but we're big about local community involvement.
All right, cool. Thank you. So I guess John, data scientist from General Mills, the founder of the social data science. He's also a graduate of the University of Minnesota and the big data program here at St. Thomas as well. General Mills was kind enough to sponsor our pizza tonight too. So thank you to General Mills for that.
We figured it'd probably be better than cereal, given this time of day.
So thanks for coming, John, and go ahead. It's all yours.
Thanks. All right, so as you said, I'm John Hogue, and if you saw NLP and you thought nonlinear programming, you are at the wrong talk, because I'm going to talk about natural language processing. So as you mentioned, this is me. This whole presentation is going to be up online. We're trying to record it. Best effort on that. But if you wanted to check out what I have on GitHub, all the code and the data sets are going to be out there afterwards. Right now there's a couple small things that are out there, but you could literally run through everything I'm going to do today. If you download Spark, have Python installed, you can run it all locally on your own machine. It's sized to that level. That said, NLP is only a small part of my job. The code that I'm writing and showing you guys tonight is not optimized. It's basically written so that you guys can probably understand it better than if you try to make it overly optimized. And the last thing is, I don't know everything. That's why I'm part of the Hadoop user group, is because I like to learn. So feel free to, raise your hand, point out some different way to do it, or ask questions, because that's what we're all here for, is to learn. So tonight, what we're going to try to cover is a little bit about what is natural language processing, why is Spark a good place for this, what is Spark ML, and how do we choose what algorithm we're going to look at. And then we're also going to go through basically how do we process and get our data ready for machine learning, and then how do we measure accuracy, and what might you do with this afterwards. So if you're not very familiar with natural language processing, it's basically going to be the study of computers and how they interact with human language. So you can think about, how would a computer summarize a book? How might a person talk to a computer so that the computer can understand what kind of commands are given? How does a computer understand what the sentiment of a sentence is? And how can a computer ask a person a question in a way that makes sense, or vice versa? So tonight, what we're going to try to go through is an example of Twitter, and what you probably can't see because this is a little bit of green text on a white, yellowish screen. But what I have here are two tweets, and so one of them is @HabitCabbage @4GoOnline. It's a good job. I like pancakes then. #BunnyMyRabbitCaptain. So I don't really find that very useful. I don't need to see that on my Facebook or on my Twitter feed. What I'd rather see are things like this. How will data science change in 2016? And then there's a link there, and then #data science, #big data. So basically, what I'm hoping to go through tonight is how can we classify natural language to say this tweet is about data science or big data, and then this other one is just kind of rubbish. So that's kind of what we have going on here. So there's just a ton of tweets out there. I think when we went through the data set towards the end of this, it was something close to the range of 150,000 tweets, and only about 20,000 of them on my Facebook or on my Twitter feed were something related to data science. Still a pretty good number. That means that I'm picking and choosing the right people to follow, but there's still, like, the vast majority of it is just things like, I like waffles. So data science in my world is going to be computer science, statistics, and business application. So that's kind of why I got this little Venn diagram up there in the corner that you guys cannot read the text on. But what we're going to work on tonight, if I call it a corpus, just know that that's the same thing kind of as the data set in natural language processing. If I interchange tweets for documents, it's just another terminology thing to note. But if you get a little spooked because you happen to see one of your own tweets up here, know that it's not a coincidence. I grabbed everyone I follow's timeline on Twitter. And if you posted it publicly, maybe this is a privacy lesson to you all, it's available publicly for people like me to analyze. So, I grabbed, I think I said, around 150,000 tweets. I think this was all back in November, so maybe your latest complaints about the family over Christmas aren't on there, but everything else should be. I used Python to access the Twitter API, and I used Hive to do the JSON parsing. I'm not going to cover that tonight because we're going to talk more about Spark. Why do we really care about Spark in this example? So Spark is going to be about 100 times faster than MapReduce. It is going to be extremely helpful in highly iterative applications such as machine learning. And when we're doing data exploration, it's also really helpful to have something that quickly puts something back in front of you so that you're not having to just sit and wait, go grab a cup of coffee, come back, oops, I forgot to grab this field, or that's not what I wanted to do, run it again. This is much, much faster. It allows you to kind of quickly work through the code, or work through your data. Spark also has APIs for a lot of the popular data science languages. It now supports Python is like a first-class citizen. You've got Scala or Scala, depending on who you're talking to. That is a functional programming language. You also have R now starting to come out. R is not fully there. It's not necessarily a first-class citizen of Spark, but it is there. And what I find in my work is that the functional programming paradigm kind of fits a little bit more with my workflow of working through data, where you're kind of doing an operation and then you want to pipe that to some other operation, do something else, pipe it to another operation, rather than, say like an object-oriented programming where you're building an application. So, the next thing about NLP is that all these documents are really tiny. So each tweet is only like 144 characters long. It's ideal to work on these in a massively parallel system. So you can have as many executors as you have on your cluster working on an individual tweet at a single time, which is really helpful. And then lastly, as Ryan alluded to, there's a lot of interest in Spark. We're now the Spark and Hadoop user group. So this is quickly becoming like a core tool set in data science. And there's a lot of standardization about how we interact with data. And you'll see that a little bit tonight as I talk a little bit about Spark Dataframes and how that's kind of becoming very pervasive in data science. So going off of this, why am I not just working in Scala? Since that's what Spark is written in, well, I have a passion for Python. I use it for a lot of things that aren't necessarily big data. I use it a lot for just scripting and automating a lot of the boring things in my life. But it also has access to a lot of great libraries out there. So I don't have to create things from scratch. Scala is still a pretty new language. There's some new things coming out there, like Breeze is the new natural language processing library out there for Scala. But NLTK has been out there for a really long time, and that stands for Natural Language Toolkit. And it has not only English, but it's got a multitude of other languages. So if you're like me and you work in marketing and you want to reach consumers in different demographics, English isn't the only thing out there. So, there's 1.4 billion people speak Mandarin Chinese. So if you want to reach like a seventh of the world's population, maybe you need to start thinking about how you process Chinese language. Then there's other things out there like LangID I'll talk about, basically helps you classify languages. So like I get a given tweet, what language is this? Like I said, Python is a first-class citizen on Spark. So what does that mean? That means that for every feature or thing that they add to Spark, they first do it in Scala because that's what Spark is written in, but then they implicitly guarantee, I haven't seen this written out, but they basically say, we're going to create something similar to this in Python. It may not be at the same time in the same release, but it is on the roadmap. And so, sometimes you're a couple releases later on, but for me, that's worth it because I would rather get things done quickly, as my last point is very clear that, less is better. So it's on data wrangling, and I don't want to have to write out extra parentheses and brackets and stuff like that. Maybe I'm going to ruffle some feathers with that, but I think that, less verbose is better for that. So as you're going through Spark, you're going to see there's two big things out there for machine learning. There's MLlib, and then there's something else that's newer that's called ML. And so MLlib has been out there, I think, since Spark 1.2. We're on 1.6 right now. Just got released. It's probably not going to be on your clusters at work, but something to be aware of. But MLlib, it's got a couple of pros for it. It's been around. It's pretty stable. You can write, your stuff in production for it. A lot of the big distributions support this in production. It has a lot of algorithms available right out of the box. And the only cons are really that it kind of is a lower level application or like lower level library. So you're working with RDDs, which are they're resilient distributed data sets, which I like to think of them as kind of just like arrays basically. And you're having to keep track of which place is which column, what data type is which. Whereas you'll see in MLlib they use Dataframes, which is, I think, a lot easier to work with. So I think that there's a lot more overhead in terms of learning when it comes to MLlib versus Spark ML. Basically, everything's abstracted to Dataframes. So if you've ever worked in Python or R or worked with a relational table, you're going to be very at home with working with Dataframes. You don't have to keep track of which column's which. It just has a name. It just has a data type. ML also provides a really easy framework called Pipeline that makes it very easy to tune your applications or your machine learning applications so that you can get the most accuracy without having to do a bunch of additional work. The cons to it, though, are going to be that it's very new, so it doesn't necessarily have all the algorithms that Spark ML has. It's basically just a wrapper for Spark ML, so it's not like one is going away. It's just one is a higher level version of the other. There are some issues with stability and documentation. That just comes with things being new. I also had a really hard time finding examples. So tonight we're going to look at a naive Bayes classifier, and there were no examples out there. So kudos to me. I'm going to have the first example for naive Bayes for Spark ML. But it makes it really hard, to kind of go through this. So when you get into Spark, you're like, oh my God, there are so many algorithms available. Do I go with ML? Do I go with Spark MLlib? And you're going to have a hard time figuring out, like, where do I even begin? And I think scikit-learn provided this really awesome flowchart. And I still use this even though this is for not necessarily humongous data sets, but provides you a flowchart. Maybe some of these numbers for how big they are don't necessarily apply in Spark, but it's a good way to start about it. So, as we're going through this, I'm kind of going from here. So I start there. So I really wish that I could read that on this screen, but it says, do you have more than 50 samples? Yes, I do. Am I trying to predict a category? Yes, I am. Do I have labeled data? Yes, I do. This is where it gets a little not necessarily applicable. Do I have less than 100,000? I have more than 100,000. That's one of the great things about Spark. It scales. I skipped the linear SVC, and I went straight to working here with the text data. So it's basically asking, do you have text data? Yes, I do. Naive Bayes classifier is what I should pick. So when I go through all of the different documentation that's out there, which, just to back up here, this is the best place to go to get your documentation. Spark has, and again, this slide is up online, so you can copy and paste it or click on the link. But Spark has a whole bunch of programming guides, and they're not necessarily exhaustive of all the things that they have available. So I would go here. It's really easy to quickly go through and figure out, which algorithms are available. So quickly, I knew that naive Bayes is what I wanted to work with. So naive Bayes, I'm not necessarily going to talk you through all the math of it. There's examples out there that'll walk you through it. I got a link here for one that's really good. It's a video, and I'll walk you through how it works. But really what we care about is the application here tonight. Otherwise, I think myself included would fall asleep. So what we care about is what is the input, what is the output. The input is data frame because we're using Spark ML. It requires an ID, a label, and then a numerical vector. So we have text data, so that seems like that might be a problem. So the output, though, is a data frame and an ID and a predicted label. So that seems like what we want. So we'll give it some data, and we'll get back a prediction. But how do we get to that numerical vector? So remember how we said we need a labeled data set? Well, this is our starting point. So right here we've got some text, and it says, what is my best option for doing MANOVA in Python? A brief Google search leaves me thinking R is the way to go. Hashtag PyData, hashtag stats. There's an ID, there's a label, data science, etc. I also have to label out the opposite, kind of my spam labeled set. So labeling data can be done a multitude of ways. You can do it rule-based, which is what I did. So basically, Boolean logic. So I say, if it includes the term Python, data science, big data, Hadoop, Cloudera, MapR, Hortonworks, etc. You get the idea. It will label that as data science, for better or worse. It's pretty fast to do it this way, but it's also going to be biased. You're going to miss things. So like when we get to the final result set, you'll see that there's one that's clearly data science, but it doesn't have anything. It doesn't have any of the terms that I was kind of searching for. So that when I built the predictions out, it didn't know to kind of assign that. It just thought it was trash. So another option that would be better or give you a better result would be manually to do it, but I don't want to go through thousands. I think I've categorized all 150,000 just using this quick search, like this rule-based searching. And so I don't necessarily want to go read through everyone's tweets. I'm sure your tweets are all really exciting, but I'm not that interested. So another option that if you work at a company, I would highly recommend you check out Amazon Mechanical Turk. It's fast, it's less biased because you have multiple people looking at your data set, and you can even have multiple people look at the same thing and see, do they agree? It's about 2 to 5 cents per task. An example here would be that they have a question, they'd say, here's this tweet, is this tweet about data science or is it about something else? You just have 2 radio buttons, and they just click on that, and then they get paid. There's a lot of people who do this third world countries. There's also students that do this. They're like, I'm waiting for the bus. I get paid like $5 to wait for the bus if I just quickly go through all of these things. The downside is, obviously, it's not free. And because it's crowdsourced, you cannot use this for PII information. So just be careful with that. But I have been fairly successful with this. There's an API for it, so you can even take your predicted data and then have someone verify it for you, and then take that reclassified data and add that to your training set. So been pretty impressed with that. I think there's a couple other alternatives out there. There's even some other companies that have like closed crowdsource groups where they basically approve people and you get them to sign NDAs and stuff like that so that you can get them to work with PII information or proprietary information. But the other thing that we talked about on Spark when we said the input was data frames, it's probably good to back up just a little bit and remind you guys that a data frame is very similar to a table in a relational database. Python data frame on R data frame. Basically, it's just like what you would have almost like in Excel. It's a very standard format, and it's very easy to work with. Spark now has it so it's distributed under the hood. So pandas basically will be distributed amongst maybe your different CPU cores on your local machine, but it's not going to scale necessarily across an entire Hadoop cluster. So they've kind of worked through all the guts of that and made it so that it distributes this data frame across the cluster, so you can do your your different column operations and things like that. But the real benefit of it is that it's named and typed. So no longer do you have to remember that index 0 is my text, index 2 is my label, and then you add columns and oh gosh, where was I? Instead, it just keeps working through that. You keep adding columns and they're all named. So here's an example of a data frame. Because I'm kind of working with the shell right now, it's just this kind of ASCII text here, but you can see it kind of breaks it out, so it's very easy to work with. Whereas if you used an RDD, it basically shows you like an array, and it's kind of messy. It's kind of hard to determine which columns are where. So we have a column that's called text, we have a column that's called ID, and then we have another column that's called text label. And for this one, I had some old data where I was going to classify Python. As you're working on your trainings, that's one of the things that you'll note is that things that, like different categories that overlap a lot, it'll be very hard to predict that with just like a search-based, rule-based training set. Because Python happens to be a lot with big data happens to be a lot with data science. There's a lot of overlap, so to try to predict between those two with just rule-based is very, very hard. So what I did instead is I kind of included all of them together and then said, how is this different than I love pancakes? So right here's an example, though, of how you would necessarily make a data frame quickly from a Hive table. You just quickly say, SQL context.SQL, select my stuff from my Hive table. Really simple. This is another reason why I like it. I don't have to remember what columns are in a table. I can just dump them all into memory and start working on it. If you're going to work on a text file, though, it's a little bit harder. My repo that I have on GitHub has basically how to run it from a text file, because if you're going to run this, you're most likely going to be running it on your local machine. So it'll go through and help you load up the text files. But if you are interested, Databricks has a bunch of great tutorials, but they also have this library that's called SparkSQL, and basically allows you to import flat files and does all this stuff and kind of hides it behind the scenes. So the way that I'm bringing in this text files, I start with an RDD, read in all the text file, map each line, split it by tabs, and then I call this create data frames, and I give each column basically a header on there. Then I'll spit it out to show you that, hey, I have the same data frame as what we were expecting. And if anyone has any questions, feel free to stop me at any point. I can always use break, but the next step is,
So sorry.
Yeah.
Your example that you created, did you create a SparkSQL table or did you create a Hive table? I understand that you have to declare a Hive context to create a Hive table, right?
So that is actually, in the newer version, that's depreciated. And now, basically, SQL context will call Hive. Like, the Hive context is basically gone, and now you just use SQL context. And if you have it set up correctly, it'll just know that when you point to a table, it will call Hive, basically, instead. You can still register a table the way that you're thinking of, I'm sure, but it will default to look at Hive unless you basically created a new table that replaces that one. That basically would be in scope instead.
So that'd be deprecated in 1.6.
I think so.
Okay.
Yeah.
It's still running on 1.5. So
Yes.
It must be 1.6.
I mean, I think it even still works on 1.6. It's just, what I'm trying to show here, as you guys probably are aware, is Spark changes extremely rapidly. So I started this a year ago on 1.2, and I'm looking at 1.6 here. So rather than have my repo be immediately out of date, I just said, hey, let's get this here so that it at least has like 3 months to live, rather than it immediately being out of date.
So I have another question.
Yep.
So when you work on RDDs,
Yep.
that's how Spark parallelize your data.
Yep.
So right now you are working on the data frames. So is it parallelized in that case?
It is. So basically, it's my understanding that the data frame is just like, it's a higher level. There's RDDs below it. So it's kind of a nicer way to work with the data, and it hides all the messy guts of the RDDs. That's my understanding. If someone knows differently, they can feel free to correct me. But
So then if you have multiple nodes in your cluster, you should be able to use all of your nodes
Yes.
when you work on data frames.
yes. And these are Spark data frames. They're not Pandas data frames or R data frames. Because if you were to write Python code and say create Pandas data frame, that would work on a single instance node, and it would not spread across your entire cluster. Good question. So the next big part about data, so we've got kind of the data loaded, we've got it labeled. Basically, all of this text is going to be really messy. Humans are very inefficient with communicating. We have a lot of extra crap in our language that we use. So we use and they don't really necessarily add a lot of meaning. We use emoticons and things like that in our tweets, and they just add a lot of noise to our data. Punctuation, computers don't really care about that. They want to care about like what is like the important things out of a sentence. So we have to do some cleanup, and the cleanup steps that you're going to take are going to differ depending on like what your application is. So like if I was processing tweets, that may be very different than if I was processing a medical document. It may also be very different if I'm trying to summarize a book, or if I'm trying to understand human speech. So there's different steps for different problems. So what we're going to work on tonight is how do we classify text? Is it about data science, or is it about something else? The other thing is that this is kind of more of an art than necessarily science at sometimes. So there's a lot of trial and error. Sometimes you go, wow, this model turned out really crappy. You go back and you make some more cleaning steps, and then you rerun it, and you get better results. Sometimes you get worse results, and then you add those back in. But the great thing is that because most of these pre-processing steps are done on individual tweets, they can be done in parallel. So this is a lot different than if I'm trying to compute, maybe like an average or something across an entire cluster, where all the different nodes need to know what each other are doing. Instead, very trivial to work on these things. It's kind of, I think the term is embarrassingly parallel, embarrassingly easy parallel. So when we do this pre-processing, we're going to look at a couple tools to help us along. So Natural Language Toolkit, or NLTK, as I mentioned before. This is like a great full-fledged library. It has a bunch of tools for if you just wanted to do your stuff locally, pure Python, not just Spark. This would just be a great resource. What I like about it is that there's a ton of examples out there. There's a ton of additional toy data sets out there to help you kind of work through stuff. And then it also has a lot of different language support. LangID is another small little library that's just out on GitHub that helps you identify, based on the text in a tweet, is this which language? So there's going to be different rules depending on each language. But you guys are probably wondering, like, okay, well, Python on Hadoop, there's Python on each one of those nodes. How do I get these language? How do I get like these additional modules on my cluster? You probably don't want to install it on each node. So what I have experimented with that I've been fairly successful with is that you have your local Python interpreter that just comes installed basically with any Linux distribution out there. But then you have on your edge node all your libraries installed to a directory, and you make that directory available like as a Linux share that all of the other nodes can look at. And then you put all of the supporting files for those libraries in that folder. And the way it works is that when PySpark needs one of those libraries, it reaches out there, grabs what it needs for it, does the processing on each of the nodes. So there's a little bit of like networking coming across for that, but it's only the library, it's not your data. So And the way that you can do this is you need to import all your local libraries first. So here I've got my standard libraries like string, regular expressions. And then what you do is you import this system module and you append a path. And then you can start importing your other libraries from this other shared directory. So, yes?
Why not send like the egg files with the job?
You could do that. I find that just like I haven't done like the egg files, but you could do, the other thing I've seen is like zip files moving around. That is one option. What I've seen in our area is like maybe we might want to like make sure that everyone's using the same version of things rather than one person uploading their own specific version of NLTK and then I try to run the code and I don't have whatever they're using. This way it's kind of, this is our standard version. But that is another way. So another way is that basically you can zip up the libraries and have them move around and then have your Python script unzip them. I'm not sure how you do the egg files necessarily. Okay. Yeah.
So to achieve that, can you use Maven?
So Maven is more of a Java. I've only seen it used for like Java and Scala. So I don't have a lot of familiarity with dependency management with Maven, but maybe someone else here might know the answer to that. I know that if you're using the Scala side, you can basically just, at the beginning of your code, add the directory for where to download the repository online, and it'll actually pull it into all of the different nodes across there. So if you're using the Scala side, it's very trivial. You just say, import this from GitHub or wherever, and it goes out and downloads it. But Python is a little bit harder because you need to have like the Spark library is baked there. The Spark instance is only an API to Python, and so it's very hard for it to know where everything else is.
I have a question about the agent.
Yep.
Okay, does the agent have to be one of the Spark cluster node?
No, so it just has to be a Linux share.
Okay.
So it could just be anywhere that all of the nodes in the cluster have access to. And you need to guarantee that all of the nodes have access to it. Otherwise, you're going to run into like one of your nodes will fail basically because it'll say I can't import this.
And how about do you submit the Spark job? I mean, the Python Spark job through that agent?
No, you don't necessarily have to. So basically what it does is that because you are changing where your path for these libraries are, you're no longer in HDFS. Basically, when Python is bringing these things in, you're using like the local install of the Python interpreter, and it's just pulling all those in for that, and then it calls the Spark API, Spark API is calling the Python interpreter at that point. I don't know if I'm explaining that very well. So, but you're basically not using HDFS when you're necessarily in your PySpark. You're connecting to like the Spark API, which is then doing all the distribution. Because it's converting all your Python code into something that's Scala, it's converting all your Python code into something that Scala would run. I don't know if that makes sense.
Yeah, that makes sense. That's a shared library.
Yes.
Shared directory for the libraries.
Yes.
Thank you.
And one last question.
About Maven, just wanted to clarify that though Maven is written in Java, it can be used in non-Java projects. So just I thought I wanted to clarify that.
Okay.
And second, about NLTP.
Yep.
NLTK you mentioned.
Yep.
I don't know if anybody has heard about Open Calais. I'm not sure how exactly it is pronounced. CALAIS. It's from Thomson.
Okay.
At one point, I worked for Thomson West, and we used to do a lot of natural language processing.
Okay.
And Thomson later outsourced it, open sourced it, and it basically is used for most accurate way to check people, places, companies, facts, and events. It does it all magically, and it's very powerful framework. So just in case if anybody is interested in using in Hadoop ecosystem.
Okay. like I said too, that if you're a pure Scala person, there's Breeze too for this as well. So good to know. And if I didn't answer your question thoroughly enough, we could talk after the meeting on this, or you can shoot me an email or something like that. I'm sure we can answer those questions later. So as I mentioned, we're going to use like LangID to kind of filter these things up. So a lot of the future steps that we're going to work through are going to be language specific. So Twitter only basically supplies language of whatever the menu that the user uses. So if I'm a Chinese user but happen to have my menu in English, they're going to report me as using English language. That's not necessarily accurate. I may be an English user, but I may occasionally write something in Spanish. So really what you want to do is you want to classify each individual tweet so that you're not applying the wrong rules to that. Then, because of this, because all of my future rules are going to be English only, I'm going to basically say anything that I have a 90% certainty that is English, I'm going to keep those and I'm going to throw everything else out. So for better or worse, I know one of the things that we're hoping to do at General Mills is how can we better understand different segments, so hopefully we'll work towards that in the future. But here what we have is the original data set up top where we've got each one of the tweets, and then now we have called this function that I've created, a user-defined function, and it adds a column that is classifying the language. So if I have a custom function, they use this UDF. So you can basically write a normal Python function. If you don't do anything in particular, it'll just run on whatever, like your master, I think your master, your Spark master. But then if you register it, it'll distribute it across the cluster. So if I give it a specific column here, it'll operate on that. So I've defined a function here, and basically it's going to take in an individual tweet. It's going to classify it. If the prediction is greater than 90%, we're going to return the language ID. So it'd be like EN, I think SP for Spanish or something like that. If we're not sure on the language, we're going to return NA because we don't know. Then we're going to return the language. So that's just a function. Like you could just write that and run that on any data set. I could just put in a random string in here and it would predict it. When I register it here, I'm registering it as a UDF. So there's PySpark has UDF as a import that you need to do. You register the function, you say what the return type is, and then now in my data frame, I can do with column, which basically will create a new column with the heading language or lang, and then I call that function on a particular column. So at this point, it's basically going to take each tweet and then distribute that function to work on each one of those instances of tweet across the cluster. And then return back this language column. A lot of my tweets happen to be English. I mostly speak English, so not really a big surprise. And then I guess one of the other things that you might do is you might filter, but I don't know if I necessarily have that as a slide. Oh, I do. So here, in the next slide line here, we've got English language data frame equals my language data frame, where I'm filtering on the language equals to English. One thing to note that I've noticed a lot within Spark is that it is much better to create a new data frame than keep copying data frame equals this, data frame equals that, and kind of do in place. It just seems to take an enormously more amount of time than if you just create a new data frame. So I also find that it's way easier to make changes on the fly. So let's say that I have 10 steps after this, and I want to include Spanish in here too. I basically can just change this rather than having to rerun like all the prior steps. I can start from wherever I made the change and work my way down. So one thing I would note about that. Next step As you can see, a lot of these are very like atomic operations. We're going to remove stop words, so of, and, the, etc. You know, these are kind of meaningless in the computation. It doesn't really help in determining what the tweak is about. And by removing it, it actually makes your computations a little bit faster because you have less words to try to care about and calculate different numerical frequencies for. But there is no universal set for this. So if I'm working on Twitter, reach like RT might be something that I want to remove because it means a retweet, and I don't necessarily care about it. If I'm doing something maybe in the medical field, maybe patient is something that occurs so often that every document's going to have it, so it doesn't really add any meaning. So it's going to depend on what application you're working on. And this is super tiny here, but what you have here is you have the original text, which is what's my best option for doing MANOVA in Python. A brief Google search leaves me thinking R is the way to go. And then what you're left with here is what's best option. So it's removing for, or it's removing my. Removes for, removes doing. You can see that it's a lot shorter. So it removes a lot of things here, but you can still see that it's mostly about Python, MANOVA, option, search, Google, R, things like that. Things that you still would say helps you understand what this is actually about. The next step that I like to take is removing any additional junk. This is where I be a little bit of a data artist. So I'm removing URLs. So a lot of Twitter and other places, they use like URL shorteners. They use things that kind of uniquely make URLs. And the problem with that is that each one of those unique URLs is going to come back to be an individual word later on, which increases how much stuff you have to do for computation. So I remove those because the unique URL doesn't necessarily add a lot of value in helping me classify it. I remove punctuation, so I don't care about ... I don't care about smileys. I remove numbers, so like if someone says like my prediction was 92%, like I did last night, I don't necessarily care about that. I might care that they said prediction, but not the 92%. And lastly, mentions. So if you don't remove mentions, you may end up with a lot of people just having to mention like famous people. So it may be like, maybe there's some data science thing came out and they were trying to petition the White House to do something. You might get like a bunch of @White Houses, and then now any news article that happens to mention the White House is also going to get classified as data science, and that's not what you want. So those are just things that I do. You may have different applications, different ways to do it. But again, kind of a before, after. So before we have retweet @Anthony Nystrom. Hopefully he's not here. I don't know who that is. But NLPy, and then they have like this minus and GT. I don't know what that is. Curated list awesome machine learning frameworks. And then there's a URL at the end. At the end, all we have are actual words. So curated list awesome machine learning frameworks, library, software, Python. So this is a tweet that the machine is starting to have a better understanding of. Yes?
Now, you said the URL itself isn't helpful in classifying, but would the content of the URL, of the article that URL points to, would that be helpful?
Potentially, if you wanted to write something that would almost be like a web crawler at that point, where you'd be appending that data and you'd have like a hierarchy. But yes, that potentially could be. I think also if you, like Twitter gives you like the little heading on like when someone posts an article of like what a tweet is about. I think if you could somehow scrape that as well to determine what is in there, I think that would also be helpful.
Even though you don't want to keep the URLs, I think you want to maybe count the URLs.
I mean, it may also be helpful to, rather than necessarily, so on mine, I just got rid of URLs for better or worse, but you might get rid of specific domains. So like, I think it's t.co is Twitter's URL shortener. So maybe anything that uses t.co, you just get rid of. But if I had socialdatascience.org/my really cool project, maybe you just truncate that, maybe write some regex to truncate that down to just what is the domain. So that might be something, but a lot of this again is kind of trial and error. and depending on how much time you have or what is good enough for your accuracy. The next step I like to take is a little bit of like what's called part of speech tagging, and so it is keeping only the important stuff of the language. So I'm only keeping nouns, verbs, adjectives, and kind of getting rid of anything that's not that. NLTK has a great library for doing this. It's already provided there, goes through, and most known words are there. What you'll see though is that words that aren't known are still kept because it goes, this might be something that is like a noun. So like if there's a typo or something like that, it thinks it's a noun. Yes?
How do you handle conjugated verbs?
So we're going to get to that.
Okay.
Yes, we're going to get to that.
Was it funny?
Tagging means essentially classifying them as nouns, adjectives, and verbs.
I'm sorry?
Tagging is essentially classifying them as nouns, adjectives, and verbs.
Yes, I think this one is a little bit simpler in terms of like it already has a list to go off of. So they've already done the classification behind the scenes, and then now they're probably just iterating through like a dictionary to say, here's John, that happens to be like a noun. I'm not great with my language, so knowing whether things are verbs or not, I'll trust NLTK, but I imagine that's what it is. I had two other questions here.
Yeah, so I'm still not wrapping my head around how, basically like how a user-defined function in Python works. Is it, Python under the hood, or is there a bridge where, the RDD, the vectors, get shared with the Python runtime, or just, I'm just curious what the mechanics are.
Yeah, so basically you can think of it as like, you've got like layers there. So you've got like Python on top, and you create your function, and then that function is going to work on something within Spark, or like some kind of like string or something like that. And then underneath there, Python is talking with Spark, which is then distributed. So like, for all that function cares about at that point is it just cares that it gets a string. And then when you register the function, all that function cares about is that it gets some type of like element that is a string, and it returns some kind of type of element that's a string. And so you're kind of like nesting different layers in there. So like the way it's going to execute is going to be probably like Spark is going to go out and grab the data that works through it and then pass it through like the PySpark API. And then that PySpark API is then going to pass that through like the Python interpreter. And at that point, it's just like a string. And it does the operation, and then it kind of rolls that back through to make the data frame again. Does that make more sense? Yeah. All right. And then one other question here. Yep.
As far as speech taggers go, which ones have you seen work the best? Because we're doing a Java project right now. We're using Data Annie, and the data scientists are not happy with the part of speech tagging. It seems to default to noun whenever it kind of doesn't know what it does, what it needs to do. So I'm wondering what your opinion is on what are the best part of speech taggers that you've seen.
I haven't worked with a ton, so mine is like the one or two that I've worked with. It's been like NLTK, just because again, for this one, when we worked through all this thing, spoiler alert, like the classifier that I create is about 92% accurate. That's good enough for me. I probably wouldn't get on an airplane if it was only 92% working. But for me, tagging my tweets 92% is accurate enough. But if I'm diagnosing a patient, whether or not they have like cancer or something, 92% is probably not good enough. So for me, I'm in marketing. We like to have things very directional and correlation and things like that. So unfortunately, I don't know if anyone else has any other suggestions. We come find you after the meetup. Perfect. A couple other questions? Yes.
So with the speech tagging, if I understood you right, you said the typos would show up as separate, probably nouns in this
Yep.
case. Why not run a spell checker?
You could. So that's what a lot of people end up actually doing too, is that they do run a spell checker. I just didn't have have time for that, but you could do that. It will take additional time, so it just depends on how much that is. In our later steps, basically, we're going to do a step where it will basically negate typos, because we're going to do like a weighting of that. So we'll get to typos in a little bit. And then any other questions? Yep.
How does it handle words that could be more than one type?
That I don't know. That may get into kind of where you're getting at.
You need to figure out the usage of the word, and that's their part of speech tagging, and that gets tricky.
And so I know NLTK, if you feed it like an entire sentence, it'll use it'll use kind of what is it, n-grams, so it'll look at like proximity to other words to try to help it. When I did this for my application, I literally just fed it like one word at a time. So mine's maybe not the best, but NLTK does have options to kind of give it additional context to kind of help it along. But again, that may slow down your computation. Again, what's good enough for your application? Right. Moving on. All right. So things that couldn't be tagged are still kept and probably default to nouns. So like Hadoop, data science. These are words that are either very new or they're concatenations of things that aren't going to be in their list. So before and after, we're keeping this. So I don't remember which ones we actually kept and didn't keep on here. That's option. Oh, so what dropped out, and then that's about it. So, and wait. No, wait's in there too. So what is not a noun, adjective, or verb? So that's gone. Just didn't happen to have a better example for this, but there are a lot in there. So again, it reduces the amount of words that we have in here, and again, boils it down into what we care about. So back to whoever was talking about kind of like how you deal with tenses and things like that. There's two options. You can do lemmatization or stemming. If I'm going to display something, I choose lemmatization because it has human readable words. If you're going to do something to try to get like the best accuracy, I find stemming is usually a little bit faster, but the problem is that words like computer and computing become compute, which is not a word. And so when you're dealing with people in marketing, they go, what is that? I don't know what that means. So instead, if you stem computing down to computer and computers down to computer, you can instead boost your numerical measures. So, if we have this example of organize, organizes, organizing, and we convert those all into organize, if you have organize as an important thing to your classifier, your measure is now 3 times higher, if that keeps happening. Another approach, like I said, is stemming, but again, it's a little bit less human readable. Does that answer your question? And NLTK has a bunch of great examples for this. I don't work for NLTK. I've just been very, very happy with it because I get thrown projects and examples are really helpful. Yes?
So lemmatization, we'll get back to the part of speech thing too. Lemmatization depends on that part of speech a lot of times, like running, for instance. It could be an adjective or a verb, depending on how you've used it. So I guess my question is, in your experience, does lemmatization or stemming produce better classification results?
I haven't done any comparison between the two. I've just done a couple very simple things. So, sorry. But you will see an example of like my lemmatization that I did just for time, and because I didn't necessarily set it up correctly, it only removed plurals. And one of the things that I ran into was that leaves, like so-and-so leaves the building, became leaf, which is not correct, and you wouldn't want that. So that probably has to do with like the tagging under the covers. But here, again, you see, instead of created becoming create, I only got rid of plurals. So notebooks becomes notes, or notebook. Days becomes day. Logs becomes log. Nerd problems, because of that tagging, it goes, this must be a noun. And just keeps nerd problems plural. So there's no nerd problem as a thing up there. So the other thing I'd like to point out too is that if you're working with data frames and you want to do show, and it will kind of truncate by default to like, I think like 20 characters, you can set this option to truncate equals false, and it'll give you this big thing. If you're working in like IPython or something, it will like start to wrap your text and it'll look god awful. But it makes for nice presentations when you want to actually show what the full tweet was rather than just the first 20 characters and then the ... So now we've basically done most of the cleanup. So there may be tweets out there that have nothing in them anymore. So you might, like someone has said, what? And there's a question mark. We've effectively replaced all that with just white space, so filter that out. What I've also noticed within Twitter is a lot of people tend to retweet popular articles and they say, @so-and-so. And the problem with that is you literally have the exact same tweet over and over and over again that are just pointing to different people. And so if you're using that for a training set, I wouldn't necessarily want maybe one tweet that happened to be very viral to necessarily dictate how your classifier works. So I tend to deduplicate at the end, and then the last step is maybe to make sure you split out your training from your test so that you can verify how well your model works. But we get to this step, and Spark says, "Hey, you just have text data. You don't have numerical data. So would you like help?" Unfortunately, it doesn't do this. Maybe fortunately, I don't know. Depends how many people are still fond of Clippy or not. But this is where we come into like how do we convert text into like the numerical measure. So data pipelining is a new thing within Spark and ML, and it basically allows you to kind of create multiple steps and just have input, output, input, output, input, output. And so it makes like these rapid iterations even faster. I don't have to worry about looping my stuff or rerunning it or anything like that. I can just have it do cross-validation and things like that. So we're going to start here where you've got clean text where it's got an ID label text. Then we're going to do another operation to it, and that operation will net us ID label text words. And then the next one is going to basically convert those words into features. And so each one of these is a data frame, and it's going to feed this all into this naive Bayes model. And what's nice about this is each one of these steps is a data frame, so you can take a look and see what's going on. And so the first step with your numerical measures is you're going to tokenize everything. So right now, this is maybe a tweet that someone hopefully is tweeting right now, what an awesome talk I did. But then it's going to basically split on white space, and it's going to make a list that is going to have each one of these words separately so that it can work on each one of those. Thing to keep in mind is depending on what language you're working with, again, I keep picking on Chinese, but they don't use spaces. So tokenizing on space for Chinese language is not going to work. So, but you're going to have a lot of other problems if you're working on Chinese. So, but then the next step is, after you have all these different words, how do I convert these words into a numerical measure? One of them is term frequency hashing. So you're going to count the number of times a word appears in an individual tweet. This also is going to typically map it to a number. So rather than having like, I do 2 in a given tweet, it's going to give you like 1, 2, 3, 4, and then the number of times it appears. And then a good example of high term frequency would be Python, Hadoop, Spark, Pandas. These are things that are really related to data science and are going to occur a lot in a lot of our tweets, or a lot of times within a given tweet. A bad example of high TF are things that are going to commonly occur and why we remove them. You don't want those necessarily in your tweet. Another thing to point out, again, I keep saying different applications are going to require different rules. Tweets are really short. They're only 144 characters. So your term frequencies are always going to be fairly low. There's only so many times you can say Python in 144 characters. So just something to keep in mind, whereas if you're doing a book and you're trying to index a book, your term frequencies may be very, very different. So we start out with that list where we have tokenized it in the step before. We basically count how many times these things happen. So we have Hadoop is great, Python is great. We have Hadoop 1 is 2, great 2, Python 1. Keep in mind we would have probably removed is, but we have great is in there twice. And then it basically is going to map these to like a numerical measure, or a number instead. It may actually do this before, but it's going to map everything so that now you just have a numerical vector. The next step is, because we want to make sure that we don't have just like words that commonly occur totally overwhelming our data, we also want things that are very infrequent. So like if we want to kind of weight those things out so that they balance out, and one of them is inverse document frequency, which is you're basically going to calculate the uniqueness of a word across all the tweets. So a good example would be like an author name. If I'm looking for a book, I go to a library. A good way for me to pick out an individual book might be to use an author name. It might be the title of the book. So if I'm looking for a data science tweet and it specifically mentions a particular white paper, that might be a great way to identify that this is about data science. Bad example of high inverse document frequency are typos. So this is where you've got things like Python, data science, etc., where people mistype things. And these maybe only occur like once out of all of your tweets. And so you don't necessarily want to use that. So what you do is you kind of combine the term frequency and the inverse document frequency, and they kind of balance each other out. There's more math out there, so if you want to go out to www.tfidf.com, they'll walk you through an example of that. But that's how you get your numerical measure. So once you have your numerical measure, you ran it through, you created a model. And so here are all your different steps. So you started with your clean text, you ran it through tokenizer. Then you had the individual tokenized words. You run it through your hashing and your IDF, which are your features. And then you run that through your naive Bayes classifier. Now you have a model. So if you want to build a model, MLlib or ML, it's very easy nowadays. I think it only took me like 8 lines of code to do it now. So as they say, like a lot of ETL, it's like 80 or 90% of your work. I'd say it's even more so nowadays. You've got a lot of stuff to do up front. And the pipelines also enable you to do cross-validation, which is very, very important in getting a very accurate model. So here's my model. Here's how I ran it. So I created a tokenizer, which again I said it had an input and an output. And then my hashing expects an input and an output, and an input and an output, and then you basically have the model at the end. So my pipeline has those different things in there, and they just chain together. It knows, like a pipe, it just goes from one to the next to the next. And then this part down here is where I'm using my pipeline to do a cross-validation. So rather than just running a single model, I'm splitting it up into 4 different smaller data sets and then trying different options for different parameters. So I have this parameter grid here, and so I'm trying different smoothing factors, and it's going to run through all the combinations across multiple different smaller subsets of my data set. And then using this evaluator, it's going to pick the best one. So the evaluator has a couple of things in there like recall and precision to help measure how well this is. And you run all this by just creating CV model equals CV, which is my cross-validator, fit my training set. Does all that stuff in there. It runs, what is it, like 8 different options? Yes?
Yeah, so if I'm reading that right, then the only thing you're parameterizing over is your naive Bayes smoothing. You're either doing 1 or you're not doing 0.
Yes.
And you're doing it 4 times with, 4 times without, looking at the average. Is that the fold?
No, the folds are going to be different subsections of the training set. So it's going to like basically look at different parts of it. and it's going to try with different sets for each one of those. Does that make sense?
But you're only looking at two.
Yes.
sets of-
You could put in multiple in here. Again, I ran all this on like a 4-year-old MacBook, so I imagine many of you guys have newer computers than me. You could easily run this. It took like 10 minutes to run through all the different iterations for this data set. So you could easily put more in there. But this is just the pipeline here, and all it takes to do the testing is you take your clean text from your testing data set. Remember, we only kept 60% for training. And then you want to do the same steps for all of like the hashing, tokenization, things like that. Now you're going to apply your model to it and do the predictions. So to do the evaluation of it, also extremely easy. It's 3 lines. You throw in your test set. You say, what is my evaluation? Like, how am I evaluating this? I'm saying it's on prediction. So, or this is my prediction column that I'm looking at. And then I want to look at the metric precision. And so across all of the stuff, it's going to compare what my original label that I started out with was, my basically what I said it was, and then it's going to predict it, and it's going to compare those two to say, how many times was I right, how many times was I wrong, and spit this out as a number. So I've been pretty happy with it, but you can take a look at the results yourself. So data science, so these are all some of the clean words that came through. They're not the original tweets. You could easily join that back on, there's another column here that I didn't show that's the ID to get the original one, but you can see that this first one didn't label correctly for some reason or another. It did include big data. The second one also didn't encode correctly, but data service, say Hadoop service, inaccurate company, that was correct. You can look at all these other ones. Most of them are pretty correct. For the all other, for my spam, if I wanted to get rid of these, this one was extremely accurate. But the one thing I will point out in here is that because I didn't classify this one, you'll see that I said that this was spam at the beginning, but this is clearly a data science one, which doesn't include any of the words that I had in my search when I was creating the original training set. So basic classification neural network, that is an error in the training set. It didn't predict it correctly. So last step, you probably go, okay, cool, I made my model. How do I save it? You can easily save the predictions to Hive by just doing the data frame writer. You can save out, you can partition by your column, save it to a specific table, specify your format, say if you want to overwrite. If you want to save the model, that's quite a bit harder. There is an open Spark Jira for it right now to try to work it out. The best option is probably to serialize it to disk. The problem with that, though, is that if you serialize your model to disk, if you upgrade Spark in the meantime, your old model will no longer re-serialize back in the new Spark. So just be careful with that. But there probably are some other workarounds, but I just couldn't find one at the time that I had available. So where do you go from here? I guess I could create a really great Twitter bot where I retweet only data science posts. I could apply some feedback to my model to say, if people favorite or retweet this, include more tweets like that, so I could boost my measures. You could also apply this to different applications. So maybe you have like a call center or something like support tickets that come in, and you want to classify like which ones are about which topics. Potentially do that. You could also then analyze using other algorithms to say like, let's summarize everything that's in data science, like what is occurring in here. So you could run further analysis on this data set. But I encourage you guys to go check it out yourself. It's out on GitHub. I'm going to probably have a couple more small changes. It should work as is. I know the training set I have out there for raw is not the most updated version, so I'll be working through that to get it a little bit better. But the clean training set that's out there, if you just wanted to run the machine learning part, that works. You'll need Spark 1.6. You'll need Python 3 at least and I'm happy to answer any questions.
So many of the statistical probabilistic statistical models work with document turn metrics or turn document metrics. Now, can Spark MLlib best handle that kind of metrics, or does it have to be in a vector form?
So which kind of metrics? So like word to vec? Word to vec?
So like a lot of models out there, like LDA is one example that you can create a document turn matrix form.
Yep.
Like you create a turn frequency and you create a matrix.
Yep.
Can Spark handle that?
So
like
Spark does include LDA is one of the newer algorithms that's out there.
Yeah, but the type-based classifier that you use here, does it have to be like you have to feed in as in a vector form? Or can it handle a matrix form as well?
Matrix form. I think it probably has to be a vector. That's my guess. Is that I think it's a dense vector is what it has to be. I'm not sure. Any other questions?
So I realize you can use some scikit algorithms, right, within Hadoop, in the custom.
You can on. It has to be on like an atomic data set. So like an individual tweet, not across all your tweets because it won't get distributed. But if you wanted to do a specific operation on a subset of your data, you can do that. It'll only work on whatever node has the data at that time. It'll basically bottleneck everything to that one spot. So it'll have to like pool everything through there.
It's not going to be a parallel trails using the algorithm.
No, it might be parallel across the cores within that node, but it won't be parallel across the entire cluster.
So what does your actual feature vector look like then? So is each measurement a list of tuples basically, or of each, there's the hash ID and then the frequency?
Yep.
So that was what actually got fed into
Yeah.
That was okay with that format?
Yes.
Okay.
So I didn't show that because it was kind of messy and looked really awful on screen because it didn't really fit. It was just a whole bunch of numbers. But yes, it is. It's basically whatever word maps to a frequency, and then you have that concept here.
And all hash IDs are just integers? Or?
Yeah. I think they're either integers or doubles. Yes.
I got another question. For the Spark submit of your data program.
Yep.
Okay. So you submit to the master?
So I haven't done a lot with Spark Submit. A lot of the work that I've been doing has just been with just like the Spark REPL. So I haven't done a ton with Spark Submit. Where you write an entire application just
okay, you're sitting on the shell.
Yeah, I'm sitting on the shell, and for this I was actually doing it with, and in my GitHub, it's an IPython notebook that'll basically just connect to it.
Do you pull the tweets like continuously?
For this one I did not. It was just a batch load, but that's another thing that you could potentially do is create again, I haven't worked with Spark streaming sets, but you could potentially set up something to do that.
Okay, thanks.
But, yeah. All right. Well, I think anyone, we've got one other question.
One more thing. So you have solved this problem in a very nice way, creating a supervised problem. Have you thought about solving it as an unsupervised way? Doing it as a topic modeling and similar?
Yeah, so topic modeling is actually what I was hoping to get to for my next step with this, was basically using LDA algorithm to basically say, what are the topics within data science and how are they related? I didn't get to that on this one, but that would be an example of unsupervised where you just say, where do these groupings naturally occur and let the algorithm figure it out. But that is in Spark ML and MLlib. I just didn't have time for it, but it's another great thing to work on. All right, well, I think we'll let everyone mill around, and if people got more questions, I appreciate you guys sitting here listening to me talk.
Thanks, John.
Just so you know, we're on microphone.
That algorithm is not